This is another video about factoring trinomials when a is not equal to 1, but it uses a different method that's called the AC method or the key number method. It's got a lot of names, but it is an alternative method. Okay, so first what we're going to do is we're going to review factoring by grouping. So if I have x cubed plus x squared plus 2x plus 2, I'm going to group the first two and the last two terms together. Now if there's a minus sign here, I'm going to group that inside because the minus sign would belong to that 2. So here I'm going to take out a greatest common factor. So x squared is my greatest common factor. And what's left is x plus 1. Now here I'm going to take out the greatest common factor, which is 2. And what's left is x plus 1. Now x plus 1 is in common here. So that can come out as a pair, just like if this was x squared y plus 2y, we could take out a common factor of y and be left with 2x plus 2. We can do that if the y was, say, an x plus 1. So in this case, the x plus 1 can come out, and what's left is 2x plus 2. So it's very similar to this problem. In fact, it is the same problem, except instead of writing x plus 1, I've written y. But this is all one thing. You can think of this as being like y. Okay, so this doesn't always work for, like, for instance, a cubic. It wouldn't always work for a cubic. But when it does work, it's very, very nice. Okay, so that's review for the next problem. Okay, so this was an example we talked about with trial and error. The way this method works is we take the first number and we multiply it by the last number and we get 14. Just like when we talked about tricks, I would take two numbers that multiply together to get 14 that would add together to get 9. Okay, so 1 and 14, 2 and 7, those are my factors. Which ones add together to get 9? That would be 2 and 7. So instead of writing 9x, I'm going to rewrite this with 2x and 7x. Okay, so I haven't really changed the problem because 2x plus 7x, that equals 9. So that's not a lie, that's still the truth. I've just written it that way because now it's special. Okay, so I'm going to factor these together and these together. I'm going to pull up my common factors. So they both have a 2 and they both have an x in common. So 2x comes out, and here there's an x plus 1 left. And here I'm going to take out a 7 because that's in common. And then what's left is x plus 1. And now I can pull out that x plus 1. So I have x plus 1 and 2x plus 7, and it's all factored for me. So this is my answer. I didn't have to use trial and error. Okay. Now, it's not that it's better than trial and error. It's just a different method. It's got its pros and cons, and we'll talk about those at the end. Okay, so let's say we have this problem. We're going to do the same thing. We're going to multiply 5 and 6 together, and we're going to get 30. And we're going to find two numbers that multiply together to get 30 that will add together to get 13. Okay, and I'm going to ignore this sign for a moment. So 1 and 13, 2 and 15, 3 and 10. Okay, notice a pitfall here because 2 and 15, they would differ by 13. But this sign says plus, so I want them to add together to get 13, so it would be 3 and 10. Okay, now I look at this sign, and this sign tells me, like, how am I going to get 13 out of 3 and 10? How am I going to get negative 13? They're both going to have to be negative. Okay, so I'm going to group these together, and I'm going to group the negative sign inside because the negative goes with that number. Okay, so I have to put a plus here because, it's not multiplication between there, it's still a plus. I'm going to take out my greatest common factor, which is 5x, and what's left is x minus 2, and here I'm going to take out a minus 3. Now, I'm always going to take out a minus if my leading coefficient inside here is negative. I'm always going to take out a minus. So what's left here is x minus 2. These, of course, match. If they don't, you have a problem. Okay, so I take out the x minus 2, and what's left is 5x minus 3. Okay, and it's factored. Okay, example 3. If I take 2 times 4, so that's 8. I want to find two numbers that multiply together to get 8 that differ by 7. Okay, so it's going to be 1 and 8. So it's going to have to be minus 8 and plus x. Okay, because the 1 goes here, the 8 goes here, but minus 8 and plus 1 is the only way we're going to get minus 7. So that's why we chose the signs the way we did. We're just going to choose the signs so that they actually add together to get negative 7. Now, does it matter how you order this? No, it does not matter. If you wrote x here and you wrote minus 8 here, it would not matter. It would just be a bit different. But as long as you're consistent with your signs and you do everything correctly, it won't matter. So let's take out a 2x here. And here, we don't take anything out, so we'll write a 1. Okay, and so now we'll take the x minus 4 out, and what's left here is 2x plus 1. And that's factored. Okay, now let's look at example 4. These are the same problems that I worked earlier on a separate video. Okay, so 15 times 6 is 90. I'm going to find two numbers that multiply together to get 90 that differ by 1. Okay, I think the ones are going to be 9 and 10. Okay, those are going to differ by 1. So I'm going to just go ahead and rewrite these here. Okay, how am I going to get minus 1 out of these? I'm going to have to make the 10 negative, and the 9 I'll make positive. Okay, and I'll group these together. I'll take a 5 and an x out of both, and then I'm left with 3x minus 2. And here, I'm going to take a 3 out, and I'm left with 3x minus 2. And so those are both the same. And then here, I'm going to take what's left, which is 5x plus 3. Okay, let's look at example 5. Okay, I'm going to take 2 times 25. That's 50. I'm going to find two numbers that multiply together to get 50 that differ by 5. So I could have done 2 and 25. Okay, so 5 and 10 are the ones that work because those differ by 5. Okay, and how's it going to work? It's going to have to be a plus 10 and a minus 5. So plus 10x minus 5x. Okay. Okay, notice I lumped in the minus sign with the number, and I put a plus in the middle. Okay, so I'm going to take out a 2x, and what's left is x plus 5, and here I'm going to take out a minus 5, and what's left is x plus 5, so the x plus 5s will come out. And what's left is 2x minus 5. So that is factored. Let's look at example 6. Okay, so I'm going to take 7, I'm going to multiply it by 12, and I'm going to get 84. I want to find two numbers that multiply together to get 84 that add together to get 20. Okay, it looks like my answers are going to be 6 and 14. So how are those going to get negative 20? They're both going to have to be minus, and we're going to add them together. And that's consistent with this sign. Okay, here I'm going to take out my greatest common factor, which is just x. Okay, here I'm going to take out a negative, because the leading coefficient is negative. I'm going to take out a 2, and I'm left with 7x minus 6. So the 7x minus 6 can come out, and what's left is x minus 2. So that's that one factored. Pros and cons. You're probably going to be less likely to remember this. You might do a few problems and you might really understand, and you might get this down, but in the long run, if you don't look at this for a while and then you come back, you're going to forget it. Whereas the trial and error, if you understand how to do trial and error, you can. It's really easy for it to come back to you. It also reinforces FOIL. Trial and error reinforces FOIL. This does not. So because you're remembering it and you're always checking it with FOIL, you tend to remember both of those things together because you're doing it forwards and you're doing it backwards, and so trial and error tends to stay with you more, whereas this maybe would not. One thing that could be good about this is that it always takes 4 steps, whereas with trial and error sometimes it could take longer. But it also could be a situation where this method could be longer because maybe you picked the right guess right off the bat, or after just a couple examples. Also, sometimes, as you saw, when you multiply A times C, you get a really large number, and then you have to find lots of different factors, and sometimes it can be a beast. That last one particularly was brutal. So, it's a trade-off. Lastly, of course, do lots and lots of practice. That's going to be, again, very important with any method.